Okay, this is from Unit 9, question 14 from the TYS homework. So what I've done here is this. I've actually drawn a sketch of the question for part 1 itself. So part 1, you are supposed to obtain expression in terms of theta for h, which is the height of C above the ground. So if you notice, what we're looking for here is h. So I've drawn the sketch because I will need a few additional points, right, such that I can actually be able to prove or to get an expression for the height h down here. So what I've done here is this. You have noticed I've actually added in this extra line here and this extra line here. I've named this point Q and this point is P. What is the objective of this is because I need to create these right angle triangles. So ABP is a right angle triangle. BQC is also a right angle triangle. So if you look at my working, if I consider triangle ABP, all right, so triangle ABP, so this is theta, sine theta is BP opposite over hypotenuse 5. Rearranging, my value of BP is 5 sine theta. Now, if you look down here, I have actually labeled this angle as theta. How to get theta? Very quickly now. This angle is theta. This angle is 90, which means that this angle is 90 minus theta. Then, if you notice, this angle is 90 degrees. So I take 90 degrees minus 90 minus theta. You will get theta. Hence, this angle over here will actually give me theta. So if that is theta, now if I consider triangle BQC, all right, so triangle BQC is this triangle here. This is 90 degrees. This is theta. I'm trying to find the length of BQ. So what I have is cosine theta is adjacent BQ over hypotenuse 1. So my working over here says considering triangle BQC, cosine theta is BQ over 1. I found that my BQ value is cosine theta. Now, how do I get the value of h? If you notice, the value of h is actually BP, the entire length, minus BQ. What I'm left with will be h. Hence, what I have is h is BP minus BQ, 5 sine theta minus cosine theta. Notice that I've already gotten the expression for part 1 itself. Moving on to part 2, I've actually taken a snapshot directly from your 10-year series. What is expected from you is to actually be able to apply the R formula. So for this portion here is actually 5 square plus 1 square square root. The 5 comes from here. The 1 comes from here. I would suggest you leave it as square root of 26. Do not evaluate this to 5 point something because it will lead to inaccuracy. So leave this one in cert form. It's the most exact. Now 11.30, how do we get 11.30? I just took tangent theta, okay, tangent alpha is equals to 1 over 5. The 1 comes from here, the 5 comes from here. You inverse tangent, you get 11.30. Now, to solve this for part 3, I think this is basics from the very beginning of chapter 11 itself. So when h equals to 3, so I use h equals to 3 here. You divide both sides by square root of 26. Square root of 26, we get to this line here. You inverse sine 3 of square root 26. The basic angle is 36.03 degrees. So ASTC, it should occur in the first quadrant. Okay, because sine is positive, so it's either first quadrant or second quadrant. So in this case, right, we use the first quadrant angle. We found that my theta value is 47.3 degrees. I will now move on to question 16. Similarly, what I have done is I've drawn a sketch. Okay, so if you look at my sketch, it's from the diagram itself. This is the horizontal distance. Then I've also indicated here that this is also the same horizontal distance. Why do I need this? It's because if you take a look at down here, okay, I will need to find the length of OB and to find the length of BH so that I can combine both of them to get the horizontal distance of C from the vertical over here. So if I begin, first and foremost, I know this angle is theta as indicated inside your diagram itself. So this is 90 degrees, 180 minus 90 minus theta. This angle here is 90 minus theta. Then if I want to find this angle here, I'll take 180 minus 90, this 90, minus 90 minus theta, which is this one here. You work it all out, okay, what you will get is theta. Hence, this angle over here is also theta. Then what we need here is this. If I'm trying to find the length L, okay, I need OB plus BH. So OB over here, I will consider triangle OAB. So what I need to do here is this. To get OB, this is the angle theta, this is opposite, this is hypotenuse. So I say sine theta is equals to OB over 10. OB is equals to 10 sine theta. Now, I consider triangle BHC. I'm trying to find the length of BH. This is the adjacent. This is the hypotenuse. So cosine theta is equals to adjacent, which is BH over the hypotenuse of 24. So I show you my working here. Cosine theta is BH over 24. You rearrange, you multiply both sides by 24. What I get is BH is 24 cosine theta. Now, if you add OB and BH together, you will get the horizontal distance, which I'll show you in my next slide. So L is equals to OB plus BH is 10 sine theta plus 24 cosine theta. Okay, if you notice, if you look at the 10-year series, the answer they provided, they rearrange. They put 24 cosine theta in front. So if you put 24 cosine theta in front, application of the R formula will give you R. Cosine, because cosine is in front, theta, the plus will become a minus. Remember I said for cosine it's the reverse. You'll get 26 cosine theta minus 22.620. How this R value is basically 24 square plus 10 square square root. Okay, you will get the R value here. To get this theta here, you just take tangent alpha equals to 10 over 24. Taking inverse of tangent 10 over 24 gives you 22.620 degrees. Some of you, I notice, okay, actually put sine in front. So if you actually put sine in front, an alternative answer to part 2 will actually give you this answer here, where the sine value is actually in front. The sine function is in front. You will get this R formula. The application of R formula will give you this if you actually put sine in front. So both answers are actually acceptable in this case. But I will actually use the cosine one over here. So when L equals to 26, okay, so maximum L. So remember for cosine graph, when is the cosine graph at the maximum? When the angle is equals to 0 degrees. Hence, theta minus 22.620 is equals to 0. The theta value here is 22.6 degrees, correct to 1 decimal place. Part 4, I shall not speak of too much of it. I've already covered it in the previous part on how to solve this trigonometric equations. But the thing here is this. Just note that for in this case, cosine is a positive ratio. Hence, the basic angle gives you 39.71. I've actually drawn this diagram here to show you that when cosine ratio is positive, it occurs in the first quadrant and the fourth quadrant. So what you can do here after this is to actually just solve it. Okay, you will get 62.3 or 320.3 degrees, which I will reject in this case because the angle is clearly acute. And this ends my presentation for the work done on the TYS.